This video shows how to process spectra in audela. I was introduced to audela by Thierry Garel last September and was pleasantly surprised at how easy it is to use. I will be processing spectra of Delta Scorpio here around the H-alpha line with a resolution of approximately 15,000. To start audela, double-click the icon on the desktop. This opens up the Audace and Terminal windows. The Terminal window provides status information and also allows you to enter commands at its command line. The Audace window has a menu on it, and if you select the Help menu option and then the About, you get the details of the version you have and the website address for the software, which is www.audela.org, where you can download upgrades to the software, etc. audela has a lot of functionality in it, but for processing spectra we need to use spcaudace. To get to spcaudace, select the Analysis menu option with the mouse and then select the Spectroscopy spcaudace menu item. This opens the spcaudace window. Firstly, we will set the image directory to where I have the files for processing. So from menu select File and then Working Directory configuration. This brings up the Folders dialog box. Click on the ellipsis next to the Image Folder field to bring up the Browse for Folder dialog box, and I will select the directory where the Spectra files are. Ensure the working directory is the same as the image directory by ensuring that the Same as Image Folder checkbox is ticked. Next, click the Apply button and then the OK button. Next, I'll show you the files I have in the directory. Note the format of them. I have 8 bias files with file names bias underscore and then the number of the file. I have 2 neon calibration files, one taken at the start and one at the end of taking the spectra. I have 10 dark files with exposure of the same duration as the Delta Scorpio spectra exposures. I have 7 dark for flat files. These are darks which have the same exposure lengths as the flats I have taken. And I have 10 exposures of the spectra of Delta Scorpio itself. And finally 4 flats taken on the same night that I captured the spectra. Now returning to the spcaudace window to process the files. Select Pipelines from the menu and then option 2A Stellar Spectrum Processing Simple Mode from the dialog box. This brings up the Stellar Spectrum Processing box. Select the ellipsis and select the first calibration file. Next, enter the generic names of the Delta Scorpio spectra. Generic name for the dark, generic name for the flat, generic name for the dark for flat, and the offset. Note here I'm going to leave the instrumental response line field blank here because I didn't use a response spectra for this spectra I was taking. Next, select We for Yes for the manual line selection for geometric correction. Leave the other fields as their defaults. And we'll select Yes for best format export. Click OK. And the Get Zone dialog box appears, asking you in French to select a box round a calibration line. So basically here we have on the screen the calibration spectra. And what we do is we'll just select a box with the mouse by holding down the left mouse button and dragging it down, and then hit OK. And as you can see, it's corrected the calibration of the calibration spectra. Now the Audace window is displayed with the neon spectra with the wavelengths annotated on it, of which you can see there. Now we look at the spcaudace window. It has the line profile of the neon spectra I took. So now what I'm going to do is I'm going to, as you can see here, there's the three neon lines, the main ones there, one as the second one, and you can see them against, as I'm pointing, against the neon spectra. Okay, so I'm going to do my calibration here. So if you look at the back, the wavelength calibration dialog box has appeared, and what I'm going to do here is I'm going to put the correct values in position in pixels of the emission lines. So that's what I'm doing at the moment. That's the first one in. I'll do the second one. So we'll look down for the offset. There it is, 271 pixels. And we'll put the wavelength in Armstrongs in there, and for the third one, there it is there, and we can see pixel position is about 678, 679. So we find the entry in the wave calibration dialog box for that. There it is, and we put in the final wavelength in Armstrongs. So that's just on our calibration. It's good to have at least 3 lines to do the calibrations on. So hit the OK button, and now we're processing our spectra. So this is going through doing all the processing with the darks, the flats, the bias frames, and it's doing everything. So we just wait a minute, and by magic, there it is. There's our finished spectra. So that's as I would expect. We have all the majority of the absorption lines here are tellurics, and there we have the emission line at H alpha. So as you can see, the best file editor dialog box has come up. So we can enter our data into here. I won't bother putting all the data into all the boxes, but I'll just show you how to put some of the data in. So we can put in the object's name, and you can put in the right ascension and declination, you know what it is, and we have the default dates and times there. Heliocentric velocity, so 0 if it's not corrected. Normalization to the continuum, you put in the methods there. You can put in your instrument name that you've recorded on the best database. Observation place, wherever it was you were observing from, and the name of the observer there. You can either type it in or select one from the defaults. So I'll just expand the dialog box a bit, and you press record, and that's it. It's saved the file in best format. So now you can upload it to the best database on the web. So now we're just looking at the FITS header for the file, and you can see it's got all the data in it. It's got how it was processed. It's got its, start, end date, basically all the fit stand, fits header stuff. If I look at the terminal window, the terminal gives us a lot of useful information in it, and what I'm particularly interested in is here, where we have the RMS field, which has got 0.08766 Armstrongs. Now what this gives me here is it tells me the root mean square error between the calibration I did with my calibration spectra against that done by software against the telluric lines. So I'm quite happy with that. It's 0.087 Armstrongs, so it's quite a reasonable RMS.